Hello, so welcome to this first class of the fourth semester. I will be teaching you Unit 4, GHS41. Okay, if you take a look at the syllabus, Unit 4 consists of two portions, that is projectile motion and motion in a resisting medium. So what I used to do every year is I would start with projectile motion first. Okay, but I think of making a change in this year. I will be doing motion in resisting medium first. Okay, so let us just go ahead. Okay, first we will be discussing about motion in a resisting medium, and it is about horizontal motion. So when we are discussing about motion, okay, it comes under the study of dynamics. Okay, dynamics is the study of a motion and the effects of the forces on the motion of a body. Okay, so that is about dynamics. That is what we will be doing in Unit 3, Unit 4, and Unit 5 of the paper GHS41. So now that we are talking about horizontal motion, so there will be displacement, velocity, there will be acceleration, and also a well-known equation that you had studied since school days, the equation of motion by Newton, which is the second law, that the force is equal to the mass times the acceleration. When you are studying the forces, okay, the motion of a body in your school days, you did not take into account the resistive force that is offered by the medium, okay, air resistance, water resistance, okay. Depending on the medium, there will be some resistance, okay. Right now we are studying horizontal motion, so let us see. Okay, because we are studying horizontal motion, gravity we don't have to take into account. Okay, why don't we have to take into account gravity? Because gravity, it always acts vertically downwards. Okay, so it plays no role in the horizontal motion because its component in the horizontal direction is 0. So that's why gravity, it won't be considered when we are studying the horizontal motion. Alright, so I hope that is clear. Over here in these questions, okay, which you are seeing, question 1 and 2, they are just some examples of some questions that we will be encountering in this semester. We will see that most of the problems will fall into this category, okay, where we have to find a relationship between the velocity and the time, or we have to find a relationship between the velocity and the distance or the displacement, and we also have to find a relationship between x and t. So how will we try to show alright, how will we derive these types of relationships? The first thing that you must remember is you have to find, whenever you are given a situation involving the motion of a body, you first have to find the equation of motion. So what is this equation of motion? The equation of motion, it is just an equation that describes the whole motion. Motion is described by forces. Okay, so the equation of motion will take into account the forces. Okay, but again, okay, sometimes it will also have to involve the velocity, distance, or even the time. Okay, so acceleration, velocity, distance, and time can all be present in the equation of motion. Okay, so next, you remember that because acceleration, force equal mass times acceleration, that we have learned. Okay, acceleration, it can be expressed if it is not constant, if it varies with distance or varies with time. The acceleration, it can be expressed in 3 ways. Okay, acceleration, it can be expressed as dv dt, or it can be expressed as v dv ds, okay, or it can be expressed as d2s dt squared. So these are the things that we can use for the acceleration. Okay, these are very simple proofs, okay, that you had done. Okay, maybe it follows from the definition, change in velocity over time. Okay, this one you can easily derive it. Okay, and this one by using v equal ds dt. Okay, the velocity is the rate of change of distance or the displacement over time. Okay, so now if you take a look, if we have to find a relation between v and t, how will we proceed? Naturally, this one contains the variable v and t. So this is what we will use. If you have to find a relation between v and s, this is what we will use. So sorry, this one is s again. Okay, but if we have to find a relation between s and t, of course we can use this one, but this one is a bit complicated. It is complicated because it is a second order differential, second order derivative. First order derivative, okay, if you are having a first order derivative in an equation, it can be easily solved. But if you are having a second order derivative, it can no longer easily be solved. Okay, so that's why we will try to avoid this. Okay, even though it can be done, but it will be complicated. All right, so if we have to find a relationship between s and t, what will we do? We will use this. Okay, what I say, we will use this, and then we can use v equal ds dt. Or first we can use this, and next we can use ds dt. Again, I repeat, if you have to find this one, v and t, simply use dv dt. If you want to find relationship between v and s, you can easily use this one. But if you have to find a relation between s and t, you will have to combine this one and this one, or you can combine this one and this one. I hope that is clear. Okay, so with that being said, okay, let us just go ahead with the questions. Okay, so just take a look at question 1. Okay, I will be doing the solution for question 1. A particle is projected with velocity v along a smooth horizontal plane in a medium whose resistance per unit mass is k times the velocity. Show that the velocity after time t and the distance s in that time are given by v equal capital V minus kt and s equal capital V over k 1 minus e minus kt. Okay, so the question is very simple. Okay, let us try to draw it. Okay, so the particle, it is moving horizontally. It starts from the point O. At any point of time, it reaches a point P. Okay, so if you have to make a particle move, you will have to supply some initial velocity to it. So the initial velocity, according to that, it is v. The distance at this point, okay, distance, it is 0 because you are measuring it from this point. The velocity is v and the time is 0. All right, the coordinate for this point, okay, the displacement, the velocity and the time coordinate, you can describe it by the points 0, capital V and 0. At any point P, the distance, let it be s. Okay, so s is the distance, small v is the velocity, and it takes time t to reach, for the body to reach from O to P. Okay, and over here you are having a force that is minus k times the velocity. If the velocity is small v, the force is kv. So it depends on the velocity. The medium, the resistive force of the medium depends on the velocity. So let's see. Okay, equation of motion. Equation of motion is, okay, I will just write it down and then I will explain. Okay, so if you are saying this one, it is the force. The force experienced by the particle at a time t and at the distance s. Okay, the force experienced by a particle by the body at time t and at distance s is only the resistive force. The resistive force is kV, right? If you see the question, it's kV. But that resistive force is per unit mass. Okay, so that's why we have to multiply it with m if it is the force for mass m. Okay, so we can cancel m from both sides. Okay, next what will we do? Okay, now just see the question again. We have to get this v equal capital V e power minus dt. So this one is a relationship between v and time. How do I know that? Because capital V, it is a constant because it is the velocity of projection. E, it is a constant. K, it is a constant. Okay, so this one is a relationship between v and t. Again, okay, we can do it in another way, but this is the most simplest what I will do. Okay, so actually to solve this one, it's a bit complicated. It is a bit complicated because it involves three variables: displacement, time, as well as the velocity. So that's why it is complicated. If we have only two variables, we can just separate the variables, one on one side, the other on the other side, then we can solve. Okay, so now we will use dv dt in place of d2s dt squared. Okay, you will be having something like this. Now we will separate the variables dv over v equal minus k dt. Next, we will just integrate. Okay, k, it is a constant. We can keep it outside. If we are integrating, okay, I don't want to put that plus c. Okay, of course we can do it in that way, but since we already have, these are the limits. Okay, these are the limits for the velocity. So it starts from the point O, from v. Okay, from point O, the velocity it's v. It ends at v, at the point P. The time is 0, time is t. So that is why I will be using definite integration. So we will be having, integrate this one, we will be having log v minus k dt, minus kt. Put the limits, capital V, v. Substitute the limits, you will be having something like this. Okay, so again, this is very simple now, just use properties of logarithm. Next, convert the logarithm into exponential. We will be having this. So this is the required expression. Okay, just name it as 1. If you take a look at that expression 2, s equal v over k 1 minus e. Okay, let me just write it down so that you will have a clearer idea. Capital V 1 minus e minus kt. So this one is a relationship between s and t. How will I do it? I have found out v. V, I can express it as ds dt. Okay. So now again, just separate the variables and then we integrate and we are done. Okay, integrate dt, integrate from 0 to s, from 0 to t. The limits for the distance is 0 to s because it travels from the point O to the point P. From the point O to the point P. Okay, integrate, you will be having s, capital V, it is constant. Okay, integration of this one will be e minus kt over k minus k minus v upon k e minus kt 0 to t. Okay, so we are done. E minus kt minus e power 0. E power 0, it's 1. Okay, so we are done. This is the required expression that we want to find. Okay, so we are done. This completes question 1. So as you can see, it's fairly easy. So I will say one thing right now. You won't find too much of a problem here. The only problem is in finding the equation of motion and in integration. Okay, so if you are comfortable in integrating functions, you won't find too much of a problem in this unit. Okay, now let us just say that question number 2. Number 2, solution. A particle is projected in medium whose resistance is proportional to the cube of the velocity. Okay, let me just draw a picture. Okay, the resistance per unit mass. Okay, again, I forgot to mention that one in the question. Okay, in the question it should be resistance per unit mass. Okay, let's see. So it starts from point P, 0. Okay, the velocity diminishes from v1 to v2. Show that the particle traverses a distance d. So this distance is d. Okay, the particle, okay, the velocity diminishes from v1 to v2. Okay, the time, we can think of this one as a starting point, even though it doesn't start from this point, but we can think of it as the starting point. That is actually the beauty of integration, okay, because we will be doing integration afterwards. You can just take 2 points, okay, that will be sufficient for us to get the limits. Okay, so over here v1 to v2, okay, the velocity, time, distance is 0, distance is d. So these are the coordinates. Okay, and the resistive force is k times proportional to the cube of the velocity, kv cube. Okay, solution. Okay, I've already written it. Okay, so equation of motion is, okay, d2 m minus m kv cube. Okay, so m and m will get cancelled. Alright, so this is what we will be having. Okay, now what can we do here? Okay, so if you see the final expression, it involves the velocity and it involves the distance d. So what I will do, okay, because I also need velocity and time, so I can express this one first as dv dt. Okay, dv. Okay, separate the variables and integrate. Sorry, dv over v cube. Okay, integrate. The limits for the velocity is from v1 to v2, from 0 to d. Okay. Okay, the limits for the time is from 0 to d. I think I actually made a mistake for the point P. The distance is d, velocity is v2, and the time is d. Okay, I made some mistake. Just make some corrections. Okay, minus kt. Integration of 1 over v cube. Integration 1 over x cube dx. Okay, you can actually write this one as x power minus 3 dx. Okay, x power minus 2 over minus 2. So we'll be having minus 1 upon 2, 1 by v square. V square limits from v1 to v2. This is what we will be having. Okay, minus minus, you can cancel them. Okay, you can actually write 2 kt. Okay, multiply both sides by 2. So we'll be having 1 by v2 square minus 1 upon v1 square will be equal to this. Okay, so actually we can write it, sorry, this one is v1 square minus v2 square v2 square equal to kt. Okay, so this is what we will be having. Okay, just name this one as equation 1. Okay, so now, okay, we also need the distance. Okay, the distance is not present over here. Over here we have got only some time and some velocity. Okay, k, it is a constant. So what I will do now is rewrite the equation of motion. Okay, remember, okay, again, okay, we were having that dv dt equal minus kv cube. This one, it is the acceleration, so we can replace it with v dv ds. Okay, so we'll be having this. Okay, I don't want to erase this first equation. I'll write it here. 2 kt. Okay, so this one is equation 1. Okay, I'm just rewriting it. Okay, I don't want to lose that equation. Next, just separate the variables dv on v square. Okay, v cube and v cancel. Okay, separate the variables. You will have that minus k ds. Integrate k is this constant. You can keep it outside of the integration. Okay, v1 to v2 and 0, the distance is d. Okay, so over here the minus 1 over v, v1 v2 minus k d. Okay, so we will be having 1 by v2 minus 1 by v1 equal kd. Okay, separate. Okay, just simplify it. Kd. This one will be equation 2. Now just see the question. The question demands d over t, right? So just divide 2 divided by equation 1. Equation 2 divided by equation 1, so that you will get d by t. Equation 2 divided by equation 1 gives v1 minus v2. This one is equation 2 divided by that equation 1, v1 square v2 square equal kd to kd. Right, so this is what we will be having. So v1 minus v2 by v1 v2, okay, times, okay, v1 square v2 square. Okay, I'm just writing it so I don't make any mistake. And v1 square minus v2 square, you can write it as v1 plus v2, v1 minus v2 equal d by 2t. Okay, just simplify it. Okay, what will we be having? Okay, all right. So v1 v2 v1 square v2 square. Okay, you can cancel them. Similarly, this one you can cancel with this. So we will be having 2 v1 v2 by v1 plus v2 equal d by t. Okay, which is the required expression. Okay, so as you can see, it's very simple. We just have to know integration and we just have to find the equation of motion next time.